Hello everyone. In this question, this is a isosceles right angle triangle with equal side length are 4 unit, 4 unit, and one circle is inscribed in this isosceles right angle triangle. Then we have to find the area of the circle. Okay. So to find this area of the circle, first I will consider this point as a, this point as a B, and this point as a C. Now I will find the length of AC using Pythagoras theorem. We can write AC square equal to AB square plus BC square. AB is 4, so 4 square. BC is 4, so BC will be 4 square also. We can write this as 16 plus 16, that is 32. So AC equal to, we can write under root 32, which will be equal to 2 into 16. So under root 2 into under root 16, that will be 4 root 2. So AC is what? 4 root 2. AC length is 4 root 2. Now I will consider center for this circle is, let's suppose, O, and if we draw perpendicular, yeah, you can say if we draw line segment like this, then this, if we consider this point as a E, then OE will be the radius of the circle, and we know radius is always perpendicular on point of tangency. Since BC is the tangent and E is the point of tangency, so this will be perpendicular. Okay. Also, if we draw line from this O to here, and if we consider this as a D, this point as a D, here OD will also be the radius, and we know radius is always perpendicular on point of tangency. Here also AB is a tangent, and this D point is a point of tangency, so this will be right angle also. All three are right angles, so this will also be right angle. So this is a forming a square because two sides are radius, so this will also be the radius, this will also be the radius, that is DB and B both are radius. Now as we know BD length is R and AB length is D, so what will be the length of this DA? We can write DA, yeah, AD equal to AB minus this DB. DA length will be equal to AB minus this DB. AB is 4 and DB is R, so this length will be equal to what? 4 minus R. In same way, if we want to find the length of this EC, then EC equal to what? EC equal to what? BC minus B. BC is given 4 units, so this is 4, and BE is R, so this will also be 4 minus R. And if we consider this point as a M, what will be the length of this AM? This M is actually point of tangency also. What will be the length of this AM and MC? There is a one concept, that is the two tangent theorem. If we write here the two tangent theorem, I am explaining you a little bit. Uh, According to this, if there is any circle and if two tangent segments are drawn from the same external point to the circles, then both tangent segments are equal. That is, this point is, let's suppose, A, and if we draw one tangent segment, this is, let's suppose, this point as a B, and if we draw another tangent segment, let's suppose this is C, then according to this theorem, two tangent theorem, AB will be equal to AC. Okay, because A is the same external point for AB tangent segment and AC. Here also A is the same external point for AD tangent segment and AM tangent segment. So this means this length will be also equal to this 4 minus r, and this length here C is the same external point, the tangent segment EC and PM. So this two tangent segment will be equal, so this means this length will be also equal to 4 minus r. Okay, I am doing this for finding the radius actually, and after finding the radius I will find another way. I will show you another way to we can find the radius also. So watch this video till last. Okay, after that we can write this AC equal to AM plus MC. We can write AC is actually 4 root 2 as we have already find this, and AM is we have just find 4 minus R, and MC is also 4 minus R. So we can write 4 root 2 equal to 8 minus 2R. Okay, if we bring this 2R this side, then we can write 2R equal to 8 minus 4 root 2. R equal to we can write, if we will take common 2, then we can write 4 minus 2 root 2 by 2, 2 get cancelled. So radius will be what? Radius will be 4 minus 2 root 2. So radius of the circle will be 4 minus 2 root 2. So area of the circle if we want to find, we can write area of circle. After this I will find another way to radius. Okay, wait for a few minutes. Circle pi r square. Pi is 3.14 and radius is 4 minus 2 root 2. We have just calculated using this formula, that is a minus b whole square formula. We can write a square plus b square minus 2ab. Using this formula we can evaluate this value, that is 3.14 into 24 minus 16 root 2 will come after evaluating this, and 3.14, and so after subtraction we will get 1.44, and after multiplication we will get 4.52 square unit area. So this is the required answer for this question, and I will show we can find radius of the circle in another way. You know, this circle is a in circle, so we have to find the in radius. There is a one formula for finding in radius of any circle, that is in radius equal to we can write area of triangle by semiperimeter. Here R is a in radius because circle is inside the triangle, that's why in radius, and S is the semiperimeter. Using this formula we can find area of triangle will be, this right angle triangle will be 1 by 2 base into height. Base is BC which is equal to 4, and height is also AB which is equal to 4, and semiperimeter will be 4 plus 4 plus AC length, that is 4 root 2 divided by 4. We can write this after cancelling, that is 8, and we can write this as a, if we take common after that we can write this as a 4 plus 2 root 2. Okay, when we rationalize this 8 plus 4 root 2, 4 plus 2 root 2 in this way, then 8 into 4 minus 2 root 2, using a, using this formula, that is a plus b, a minus b equal to a square minus b square. So I will use this formula. Here a plus b, a minus b, so this will be 4 square 16 minus 2 root 2 square will be 4, 2 square will be 4 and root 2 will be 8. So 16 minus 8, this will also be 8. So 8 get cancelled, so we can write radius equal to 4 minus 2 root 2. So in this way we can also find the radius in radius of any triangle. Sorry, circle. Okay, but this is a isosceles right angle triangle. So for this in radius will be also there is a one formula, that is perpendicular plus base plus minus h, that is hypotenuse by 2. This will be the in radius formula also for right angle triangle. For inside right angle triangle, when we have to find in radius, then this formula is useful. But for any in radius for any triangle, this formula is used. So memorize this two formula, which is very useful. Okay, thanks for watching this video, and please like, share and subscribe this channel also.